Let's look at histograms and polygons, column graphs and line graphs. So histogram is of course the column graph that we use in stats. Ideas, when we're constructing a histogram, each column we center it on the score. Sometimes those scores are called the bins. We all usually join the columns up with no gaps. We put them next to each other. So there's a frequency histogram for our pet example there. That would be a cumulative frequency histogram. So we start adding the frequencies on as we go. The polygon, the line graph. Now, what do we do here? We plot the points at the center, so immediately above the value, as you would with any line graph really, when you think about it. So there's the plotting. But when we draw the polygon in, we actually start it at the previous bin, so not that you could have got -1 pets, but where it would have been, and then end it at the next one, so where 5 pets would be, and there's our polygon. And the reason we do that is this connection between area and probability. So the actual area under the curve ends up turning really the probability of the thing, so that's why you need to join it up. Now when you draw the cumulative frequency polygon, however, that's different. You don't go to the middle. It's like drawing in the diagonal. So you start off by drawing the diagonal and then go to the next vertex, next vertex, next vertex, and so on. That's also known as an ogive. So you might sometimes see that word. Now when we group the data together, because sometimes it's not practical to list every single one if you've got lots and lots of data. So you group them into classes. So guide, when you're choosing the classes, they need to be inclusive and not overlapping. In other words, one number could only fall in one class. What do you do with ones on the boundary then? Well, you make a decision which class you're going to put that in, but you need to be consistent. So if you put the top end in the class, then it's got to be the top end of each of them. You can't change your mind along the way. Usually, if you're presenting data, you would then say how you've handled that data. If you have got ones that fall on the boundary, you'd make a note in your presentation. You'd say, oh well, this is where it was placed. Determine the number of classes you're going to use. Yeah, somewhere between 5 and 10 if you're going to do a presentation. And then intervals, then you can work out what it would be, because they need to be the same width. You need to have a consistent width. So whatever the range is divided by however many intervals you're going to use will tell you how wide you're going to make these things, but you know, round up. Now when you're working out your calculations, then you assume everything in the class has the value of the centre or the median of that class. Okay, here we go. We've got height in centimetres of 300 students, and here are our classes. We're going from 120 to 130 and so on, so up by 10 centimetres in each one. Using our frequency distribution table, we're going to find, so the mean, it'll be a median class, not a median. So we're saying which class does it fall in. Modal class, the variance, and the standard deviation. Here's our frequency table. Average. When we were doing it before, we just simply said it was the sum of this column. But in this case, I have to divide by n. And the reason why? This is not a probability distribution table. This is a frequency distribution table. Remember when we did stats with a probability distribution table, here I would have had the probability of it happening. So it would have been 16 over 300. This one would be 24 over 300. Well, because I'm just dealing with frequencies, then my formula needs to be over the 300. And for ours, there we go, 156.5. Our fx squared row, that was the next one we used, so we could work out our variance. But again, we need it over n, because we're not dealing with probabilities now. We've got frequencies, and we get 262. Deviation is the square root of variance, so 16.21. Redrawn as a cumulative frequency, you'll notice I've now made the value the class centre. So the average is 156.5. The median class would be the 150 to 160 class. The modal class, the one that happened most, also happens to be 150 to 160. Variance we saw was 262.75. Standard deviation 16.21. Use the ogive to calculate the actual median, not the median class. Okay, there's my cumulative frequency. Draw in the ogive. Median, I want to know exactly where 50% is. 50% of 300 is 150. So read along here. Now it looks like it's 155, but no. Let's work out where that is on our scale. So we've hit 150. What is the X value or the frequency down here? That's what we're trying to work out. It looks like it's 155, but is it? I can use similar figures to work that one out. There would be my calculation. 150 plus 150 minus 99 over 100 times 10. We're using similar figures. So I'm playing with ratio. I'm going from 150. I want to know what ratio that is of this 10. What fraction of the width? So what fraction of 10? I know that I've gone from 99 to 150. The ratio, well, there's the difference. The Y values have gone from 99 to 199, which is 100. So that ratio is what I'm looking for. And it turns out to be, it was very close to 155, but it's 155.1. That'll do it.